So good afternoon. This is Vax to Kubernetes, Ticketmaster's transformation to cloud-native DevOps. This talk is a little less technical than my predecessor. It's a little bit more storytelling and some of our challenges and our journey through this whole thing. So we'll explore the journey so far. The days of operations versus development challenges, the days of the transitional phases where we're trying to play games of hot potato and throw things back and forth over the fence at each other. And then finally, our journey of transformation to evolve 200 products to a cloud-native format. So I will share my unique perspective as a very long-term veteran at this company who's seen it all. I have seen everything from artists screaming at us because their ticket sales have queued for way too long and the fans are upset, to everything from receiving a special box of swag from the promoters because we did a fantastic job getting those tickets moved out the door and had some record-breaking sales. So while you may have heard about our cloud transformation journey in other formats, I'm here to give you a little bit of a view from the trenches. Let's see if my slides actually switch. I got to manually do it. Okay, my name is Heather Osborn. I'm Senior Director of Systems Engineering for Infrastructure. I'm coming up on my 20th anniversary with the company. You say 20 years, what? Who works at a tech company for 20 years? I always joke that Ticketmaster ate my youth, and it really kind of did. So it's an anomaly that I've been so long with the same company, but this comes because Ticketmaster has provided me useful and interesting, effectively, entertainment to keep myself engaged in the job. Prior to this, I was job hopping. I was doing the startup shuffle, jumping every year or two because I got bored and had to move on. So the unique challenges that we see at Ticketmaster have kept my interest, and the changing of technology over the years has actually just made the problem slightly different on new technology. I want to see what happens next. My motivation for change? I've been on call for 25 years, give or take. And nobody wants to be on call for 25 years. That's more than half my life. I can't imagine any of you enjoy it. So let's find a way to get ourselves out of this habit. Let's effectively replace ourselves with a small shell script. So how did I get into tech? I got into tech sideways. I went to school for journalism. I wanted to be a writer, but I like solving problems. My friends would go, hey, I can't get my printer going. I know you all love printers. I'm going to pull off to the side, help you with your printer. Oh, you want some help with your computer? I'll help you with your computer. So what happened was I ended up sitting in my car reading tech books, reading UNIX manuals, reading network guides in my car at lunch, and basically accidentally ended up as a technology person. So what I want to do to reduce my on-call is provide more resiliency to my products, more automation, and get fewer calls at the end of it all. In my spare time, what little spare time I have, I'm a music and nightlife aficionado, and I'm an avid long-distance runner. Both of those things are diametrically opposed to being on call. You can't hear a page in a loud nightclub. You can't get back to your car when you're 6 miles away on foot to deal with the problem in a reasonable time. So I want to fix these problems so I can enjoy my social life without having to worry about where I am and what I'm doing. So here's a quick overview of our journey. Let's give a little background on this company. We're a 40-plus-year-old company, tech company. So I'm going to also talk about our move from an uncomfortable move, rather, from our siloed waterfall organization to a more modern DevOps organization. I'm going to then talk about our cloud-native format for transformation. Still speak English. Why are we doing this? What are we doing? And where are we going from here? So I like this image. I think it very accurately depicts what we're trying to do. It's like turning a ship. This is a giant aircraft carrier. The planes still have to land on it no matter what it's doing at the time. Ships don't have brakes. What they got to do is change the propulsion, go a different direction, keep the plane still landing on the ship. So what I want to show you here is that regardless of how big your 40-year-old ship is, you can still turn it and get the company moving under a major reinvention to get no matter where you are in the tech timeline. So let me give you a little history on Ticketmaster. We're a publicly publicly traded company. We got $7.6 billion in revenue. We were founded in 1976 at Arizona State University. Just a couple folks putting this project together. 1996, Ticketmaster.com launched. I started in 1998. At that point, I was a jack of all trades. I was a network admin, I was a database admin, I was a deployment engineer, operations systems. At that point, we were running a precursor to ASP, IDC HTX. When we told Microsoft about this, they went, what is this? Why are you doing that? And it wasn't very feature-rich, but it was very fast. So that's what we were doing to sell tickets when I started. We went from there to a LAMP stack, and then we moved to a more Java-based service-oriented architecture, smattering of the other technologies mixed in. So in 2010, we merged up with Live Nation, and we started our transformation journey in 2011. So what do? Our platform powers over 26,000 Live Nation events to millions of fans worldwide. We've got sports, things like the World Series and the NFL. We've got concerts, things like Adele, Taylor Swift, one of our favorites, Garth Brooks. We've got theater, Hamilton. Everybody's all into Hamilton right now. So we've got over 53 million fans in 40 countries. We have 484. I just updated that today. So getting the most current numbers, 484 million ticket transactions. We own and operate 167 venues, and we've got more than 18 unique, that's 1 billion. As you can see from the site, we've only got 18 visits to our site. Let's go home. So 60% of our traffic, as of the point that I left LA on Monday morning, is on the mobile. It's probably more than that by the time I got up here. So this is a split between app and mobile web. And Ticketmaster is a top 10 e-commerce site. So this is a simple statement of what we do. We power unforgettable moments of joy. There is a Live Nation event. You're laughing. Oh, come on, you know you got the love for the Ticketmaster. Somewhere in the world, every 20 minutes is a Live Nation event. So this is a simple statement that we have huge scale, and we're literally in the business of selling fun with this huge scale. We also have some pretty big challenges related to this scale. We have a fairly unique phenomenon where we create a self-inflicted DDoS every Friday morning. It's part of our business. Every Friday is Black Friday. Our inventory is unique. You can't order more. It's not like you can make a new TV, not like you can print another book, put it up on Amazon. No, this is unique inventory. So this is 70,000 fans are going after the same 30,000 Beyonce tickets. There's going to be 40,000 people pounding on the site, pounding on the web app, pounding on the voice recognition system. And we have to be able to deal with that capacity. So this has posed unique hardware and software challenges over the year. The hardware, I know that sounds strange, but we've had years worth of vendors saying, that's not possible. We run CNN. They handle this traffic fine. You know, they have a lot more than you. Like, yes, but we're concentrating that into a minute of an hour, all of the traffic at the same time. So that's what you get at the end of it. And as well, this traffic pattern affected the people pattern. The divide between operations and development was kind of expanded because of this behavior. And I'll get into that a little bit more later. So this slide tells us a little bit about, I knew I'd get a laugh out of this one. So we've got 21 ticketing systems, over 250 unique products. We've got 1,400 people in the product and tech organization. We have a custom private cloud with over 20,000 VMs across 7 global data centers. Over 15,000 unique network endpoints. This includes the venues, the arenas, the kiosks, and all of those. And we've got over 60% VM growth in the last year. So this picture right here, it's the Museum of Arcane and Archaic Technology. So after chatting with a few attendees prior to today, I realized that a lot of people might not actually know what a VAX is. So you see my title and you go, wait, VAX what? So to steal it from Wikipedia, a VAX is a discontinued instruction set architecture by DEC, Digital Equipment Company, from the 70s. It's assembly language programming friendly, and it's known for managing virtual memory. So to take it a step forward, this arcane technology, the native operating system VMS, Ticketmaster rewrote it. We have TM-VMS. It was rewritten by us to do exactly what we do best, and that's sell tickets and process unique inventory. So as part of the infrastructure team, I don't want to spend my weekends shopping yard sales for Vax parts, right? So what do? We virtualized it on Linux. And this is not part of our an entirety of our tech stack by any stretch of the imagination. I believe, though, it gives you an interesting perspective on where we fit and how we have to deal with this complexity to get these tickets out the door. So with your little bit of tech background now, let's talk a little bit about our people history, which at this point was pretty similar to what you're seeing right there. So we were siloed. And silo is a bad word unless you're talking about grain or missiles or other things that you should keep in silos. I came from operations, and we were responsible for software deployments, monitoring, all alerts and escalations. I recall getting a call while I was out at our Chicago data center. Hey, Heather, the internet's down. What? The internet's down. What do you mean the internet's down? Well, we're having problems with the site. What do you mean problems with the site? That's what we were responsible for. So we'd get the customer service inquiries. What's the customer's IP? The customer said they got great seats and then they lost them with an error. Well, what's the error? I don't know what the error is. What's their IP? Let's look it up in the logs. Let's figure it out. Let's log a bug. Customer service is going to nag. When are you going to get that bug fixed? I don't know. We're not responsible for fixing the bugs. We're just responsible for reporting the bugs. So that was operations. We had the business disruption. Something's broken. It might be a software bug. It might be a system bug. We'd have to figure out the problem. We'd get some angry clients breathing down our neck. We'd have to deal with that. We'd get some profanity-laced Twitter streams that the code of conduct dictates I can't repeat here. That was us. So the old days of supporting those big Black Friday on sales that I described in the previous slide, that was all on the operations team. So we would get up at the crack of stupid to get up there, watch the on sales, watch the systems, watch the tickets sell, wait for application failures, look in the logs, watch the network graphs, and so on, wait for the systems to fall over so we could react to them at the time. We'd even manually throttle traffic that we thought didn't look like it was a real person buying tickets. I'm a night person. The crack of stupid was not my time of day. So I was especially not fond of it when things weren't going right. I laughed because I was walking around supporting on sales carrying these, and everybody would go, "Are you drinking Jack Daniels?" Like, no, this is iced tea, but I felt like I should be drinking Jack Daniels at 8 o'clock in the morning. So I love the excitement of on sales, and delivering value to our clients and our fans, doing something good, delivering those unforgettable moments of joy. But I did not appreciate the caffeinated stress. And the other side of the silo, my slide's not changing. Oh, that's why my slide wasn't changing. So consequently, we held everything very close to our chest. If we were going to get called out on it, we were going to know exactly what changed. We were going to control everything. So the other side was the development teams. And we can't say they were exactly doing anything wrong. This was what their job was. They just had a very contradictory goal than what the operations team had. We had stability. They had moving forward. So they were driven by product urgency. They were responsible at the time to market on features. They were very good at throwing things over the fence at us with very little information about how to support it. So we, as operations, would postpone releases that weren't in the interest of stability. Things that were of major interest to the business and staying competitive in the market, we would push them off in favor of the stability. We wanted to get to the major on sales. We didn't want to make changes that were going to affect us at 6 o'clock in the morning. We didn't care at all about that shiny new button you wanted to push out because that shiny new button was potentially going to break our site. So what do we get from this? We get slow innovation. We get animosity. We get burnout. And friction was an understatement to what we were experiencing at the time. So Here's an example of the steps to get a new application deployed. You can see that there's a huge amount of churn, bouncing things back and forth over the fence to get anything done. It's a bad game of ping pong. You submit a JIRA ticket to get a new environment built out. The cloud team gets the hardware. Submit a ticket to the data center ops to install the hardware. Follow up with the cloud team to set up the Zen pools. Deal with the ACLs, with InfoSec and the network team. The systems engineering team would have to build out their RPM packages. We'd need to make the packages available, so we'd have to use our configuration management to push them out. And then we'd work with application support team to release software into the new environments. QA would test the software, we'd get a JIRA ticket asking to push it to production, and a lot of times we'd have to loop back through the steps 8 and 9. The other thing here is step number 8 calls out an application support team. So we weren't just siloed dev and product, or dev and operations, we were also siloed within the operations team. We had a separate application support team that was the ones who dealt with the deployments, dealt with any of the monitoring, dealt with fixing any of the things that came up right away, but we didn't have privileged access to the systems to even look at var log messages, to debug things further, to pull up data to log properly in a bug. So we would have to open a ticket to the system administration team, wait for that answer, give that to the developers to fix things. So as you can see, this is not sustainable in any way. So many places where this process can break down. And it did, and it did, and it did, and it did. We desperately needed to fix this. And that's when DevOps was becoming a thing. So we went, hey, you know what? DevOps sounds like a great idea. Yay, DevOps. So let's give Dev access to all of prod. And we died a little inside. Seriously, we thought our lives were over. We thought some crazy developer was just going to wing something over the fence, launch some software that was going to blow up at most inopportune time, probably on Thanksgiving, the day before our biggest on sale at 6 o'clock in the morning. So there goes our work-life balance. We're doomed. But in our darkest days, we were also told that Dev would also be responsible for their own releases. They would be responsible for their own monitoring, answering their own pages. So there was a light at the end of the tunnel. So what we did, we got the contact information for the developers. We had never once had the phone number to call a developer after hours. We now had that all set up in PagerDuty, and the world was our oyster. We got some significant training program going for the developers to teach them how to handle operational tasks, give them training on load balancers to teach them how to set up their stuff in VIPs, and give them the ability to drop servers out of service when they were having problems with it. Give them access to some of the monitoring tools and give them some instruction on some of the monitoring tools. Teach them how to build their own VMs. Let them start this from scratch. Let them run with this. So let's make these guys self-sufficient, make it a partnership instead of an adversarial relationship that it had been. But this is not unique to us. I know all of you have either moved through the DevOps journey, are moving through the DevOps journey, or lucked out and started out as a DevOps native company. But I don't have huge faith in that one. So, almost, but not quite. This first year, sure, we got started, but there were all these flaws. We had disparate monitoring. Nobody could see the big picture. We didn't have a framework in place to do this. So it was a little bit of finger pointing among service teams. Suddenly we end up where we don't know what dependencies there are, we don't know what the endpoints are, we don't know what the consumers of various services are, and we don't necessarily have it documented. Something breaks, who did we go to? We used to go to operations. Operations used to know. They installed everything. They knew when that went out. They knew who the contact points were. We didn't even have a service catalog, or a functional service catalog rather. I used to joke, or I still sometimes do, that I was the Heather service catalog because I had most of that information in the back of my head. I did not want to have that information in the back of my head. There's much more useful things to put there. So, and of course there was a bit of reluctance to take on unfamiliar work. The ops team had previously been training wheels. You could still log a ticket and we would still help you out, but we needed you to be able to do it yourself. Then something happened that forced the issue. And before I pull the slide up, let me say that this was not DevOps that caused this issue. Don't make any mistake. It was not DevOps that caused it. It was DevOps was how we fixed it. So I won't go into too much detail here. But let's just say that DHCP sometimes does not behave as intended and can wreak some serious havoc. So this was a turning point. This was a catastrophic failure of our on-premises cloud infrastructure. All hands, former dev, former ops. We had to work together for days to get things resolved. We held hands and jumped into this big fire. So this event was actually 2 years ago this week. If we hadn't started on the DevOps move, how many people would have been helping? Probably about 20. That was not going to get us recovered quickly. If we hadn't gone through the process of training more than 200 people and given them the production access as part of the DevOps transition, we would probably have taken weeks to get back to normal. And this is including primary systems, primary sales systems. We were back selling tickets within a couple of hours. We were completely fixed within a couple of days. So this event confirmed our buy-in to this new model. Let's do this again, once more with feeling. So we had a couple more steps to take to get our fully established DevOps model going. Dev team started appointing fire chiefs, so this was an on-call / operational / deployment team. They would dedicate their week to doing that. They didn't need to wait on us, so it improved time to market. So monitoring starts waking up the appropriate team. Like I said, we got pager duty going. This is great. And it woke up the team that knew what the change was, so there was no flail when you're trying to find the problem. Teams started reporting their own business disruptions to stakeholders, because who else would know better than about what was going on than the team who designed it, deployed it, built it. We embedded some operational team members in with the dev teams. Let's teach them a complex task. Let's show them, let them do it, tell them how to fix it, and move on, let them take it over. We built out a service catalog, so no more Heather service catalog. And the development teams also started jumping in and supporting on-sales, which was fantastic, because not only were we suffering, they were suffering too. No, it's not all negative like that. The time for repair was so much quicker because they knew how the software was supposed to work. They now had some visibility in what the traffic looked like when their software started acting up, as opposed to before where we just logged a bug and said, look at it, look at the logs. So now the teams were autonomous. And that means we're done, right? We don't need to do anything else. If I had a real mic instead of the clip-on mic, I could do the mic drop. But as somebody from the music industry, I know that dropping a mic is a really bad thing to do. So now we've got the people problem fixed. We need to fix the technology problem, and we've got a long way to go still. So why should we transform? Well, I talked about these on-sales, and we're always prepared for this Black Friday. Well, what that means is we have a ton of idle compute resources. We're always scaled out for Black Friday. So that's highest peak plus 20%. We only needed that for a couple of minutes every day during the on-sales. We bought, owned, and operated at peak scale at all times, and it's an extremely expensive way to operate. So we needed to move to an on-demand model instead of always on. At the very least, the hardware upkeep costs, which massive infrastructure built out to support the Black Fridays, we would age out of the hardware rather quickly, basically by the time we got it all built out and deployed. So we also have things like infrastructure and security maintenance. The coordination was nearly impossible. I mentioned we had 200 teams. So just upgrading to something like a new version of MySQL, we had to touch hundreds of production databases, 2 years to complete, coordination with a couple of hundred teams, like I mentioned. By the time we finished, it was time to upgrade to the next version. And we have shared resources with varying degrees of tech maturity and fault tolerance. So I'll give you another database example. We've got an Oracle database. We need to play to the lowest common denominator about fault tolerance. So you've got one product that can fail over to another data center, no problem. We've got another product that doesn't have failover. We've got another product that doesn't have any DR. We've got a product in the UK. We've got a product that can't be down during business hours. We've got a product that can't be down after business hours. All of those things are using the same database. When do you do maintenance? So I'm really kind of tired of coordinating 200 ducks. And we need to find a better way to do it. So we've made it this far. You now know what the people problem was and how we solved the people problem. And we know what the tech problem is that we need to solve. So let's talk about the next step. So this is our evolution of time to release. We had the pre-Devops, the siloed organization. We've got a few weeks in there. Like I said, it was every 2 weeks or so to release something because we couldn't do it any more often than that without losing our minds. Then we moved to DevOps. They can do the releases themselves, so it only takes them a week to do it. No problem, that's great. But we need to still move a lot faster than that. Our platform, which would be our software, our systems, and our teams, was not designed for dynamic scaling. We were always on in the most painful of ways. So we think that moving to this new model, this cloud native, we're betting on it. It's going to get us from the dark days of extended release cycles to multiple in a day. This will improve our agility as a company, and it will give us a drastic reduction in our time to release new products. Ultimately, give us higher visibility because we will know exactly what changed. When you're releasing more frequently than every 2 weeks, you don't pile everything on. So what does transformation mean to us? The most primary part of this is maturing the tech stack. So tech maturity model, we actually feel so strongly about this that we put it out on GitHub for you. So this is, with this tool, we're basically assessing things and getting them to a consistent state. We're spending more time innovating and less time being busy with effectively day work. We're using a common set of guidelines to guide products to. We're increasing visibility for better decision making. We're gravitating toward consistency amongst the teams. Remember I said we had 200 products. For the most part, those were developed by disparate development teams, not even using the same software. We need to use standard components instead of custom-built things. And we need to invest in finding root causes instead of just the symptoms. So what are we exploring for tools beyond that once we've established the tech maturity of a product? We're doing things like Docker. We're containerizing so we can build, ship, and run all in one package. We are doing cloud enablement. We have a team that was putting together governance and guidelines over using these new technologies. We're using AWS, leveraging the public cloud for agility and dynamic scaling. We're using Terraform, or is our homegrown version of it, but desired state configuration, so we can do repeatable releases and repeatable product build-outs. So we've also had some training to get everybody up to speed on all of these new technologies. We've got some Kubernetes to bring the release time down to minutes from the weeks, months, days. And we have a clicker that's not working. We've got a CoreOS partnership to let the makers make. So we've got Tectonic and CoreOS. We've got a layer now from which to abstract. So let me show you one of our first examples of products that have undergone this transformation. So this is our new Ticketmaster web platform. It runs Kubernetes. This was actually partway through the transformation process. This started out as a native AWS web app, and it was scripted, deploy, and so on. But it still required a bit of manual intervention prior to that. With Kubernetes and Tectonic, we got it to a 60-second deploy down from 20 minutes, which 20 minutes is still great compared to what we had, but 60 seconds is fantastic. And there was a lot more confidence because it was fully automated. So we're able to get this high confidence release, much more rapid pace, and get new features out. This new platform supports both our desktop and mobile applications. So this is one thing that we can just package up nicely and get it moved to this new cloud native format. So what are our next steps? We've got a hybrid cloud. We learned as we were going through this, we're trying to get things on AWS. We learned that AWS isn't suited for everything. We need to not only mature our technology, we also need to get things ready to move to the cloud. And that's a lot of work. That is turning a ship. So on Kubernetes, we can add some resilience, and we can help assess and mature the products and give us time to do that. We're betting pretty hard on Kubernetes. We're trying not to keep our head in the clouds, and we're not going to forget that some things don't forget. So we still have a lot of pets. We're trying to make more cattle. We recognize that some workloads are better in AWS. Some of them are better in Kubernetes on AWS. Some are better in Kubernetes on-prem. Some are even better in bare metal. Public cloud is not cheap. We learned this. You can't just lift and shift. So if you have an application that's always on, that is not going to be cost effective. You are going to get really expensive really quick. Even though I called my talk VAX to Kubernetes, some applications are going to perform better on-prem. We're not moving our VAX into the public cloud very soon, maybe ever. I would be an interesting challenge. We could. 10% time, we can do that, So we've also got some legacy applications that would require significant redesign to remove some of the dependencies that won't let it be a native cloud application. So we've got some interesting caching. It's like cloud caching. It looked like it was hyphenated. I'm like, what's cloud caching? We've got some caching. We've got some NFS dependencies. We've got lack of failover. We've got persistent storage. These things are not necessarily going to go to cloud native nicely. So it might be a state where we leave things to kind of age out and go with the net new, build out a new product. Probably be quicker than retrofitting an older product. So we want to also want to use Kubernetes to ensure that we have a minimum viable standard for applications moving forward. We need to be able to maintain our applications. So we don't want to shoehorn things in there. We need to have something that is able to reside on its own. So we need to know that if we put an application up on AWS and one of the EC2 instances drops off the face of the planet, we want to know that it's going to recover without us getting paged to do it, because that is going to happen and we have to be able to deal with it. So we want to record that it happened, but we don't want to have to react to it. So the container orchestration with Kubernetes can help us with this, but the application has to be resilient enough to be recoverable. So we also need to take advantage of the autoscaling, especially if we're in the public cloud. Like I said, we can't be always on in the public cloud. We need to be able to scale up and use as needed. So we can't fall into the same trap that we did on-prem. And as I mentioned before, we have 20,000 on-prem VMs, not counting anything we have in AWS. No one manually wants to manage these at all. We need to have self-healing, auto-scaling applications to significantly reduce our overhead. So you can see it's a lot of work to turn the ship. Just like we can't stop the ship to land the planes, we can't stop the site from selling tickets to make these changes. So we need to do it behind the scenes. Rapid change and agility are what's going to keep us relevant. Cloud native is what's going to enable us to do this. But as a systems engineer, I can see that we have a ton of work to do still. I'm excited to play with the new toys. Keeping my interest, the way to solve our Black Friday issues in new and different ways. At the end of the day, super excited to see ownership, super excited to see self-sufficiency, and rapidly advancing our new features. Things you may have heard in the news lately, verified fan. These are things that are moving my most entrenched days of operations into a different playing field, different teams who have a little more direct hands-on with it. So I'm not the only person to get woken up in the middle of the night anymore. There are more people getting woken up in the middle of the night, but let's move away from waking anybody up in the middle of the night. So I'm in this business because I like solving problems. I know that's the thing that brings you here too. So I hope this talk has given you some insight on things you can investigate for your own organization. If a company whose technology and human infrastructure has grown up organically around a custom-written VAX operating system, if we can make the move to the cloud-native applications, so can you. So here's my email. As you can see by the simplicity of my email address, I've been with the company for ages. And I've got a sorely neglected Twitter that you are more than welcome to hit me up on, and I will probably answer you because I should be using more Twitter. And if you are interested in solving problems, like I am, we are always hiring intelligent engineers that like to resolve interesting problems. With that, any questions? Don't ask me for free tickets because I don't have those.
Thanks. So we have time for one question. Go for it. No pressure.
In your journey from transforming old technology to new technologies, did you hit some licensing issues when moving to the cloud era? Out of my head, I think about Oracle databases, for instance.
Our Oracle databases are still, as I mentioned, some things are better on bare metal. Our Oracle databases are pretty much still on bare metal. So some of those things we haven't had to work through yet. I can't say that it's not going to happen. You know, we were exploring Aurora on AWS, so there is possible transformation, but it's not going to be just again, lift and shift is not necessarily the way that we can go, because there are the challenges, the licensing challenges and so on.